In this video, we're going to investigate speed and velocity. Why can't you fool the average speed cameras? So unlike instantaneous speed cameras, which just record the speed at that particular point, the average speed cameras work out the average speed of a vehicle by monitoring it at the beginning and the end of a journey. Whereas with the instantaneous speed cameras, you could just slow your vehicle down as you approach the camera and then speed up and exceed the speed limit again as you after you pass them. With the average speed cameras, it works out your average speed across a journey, and therefore, if you've been speeding at any point, your average speed is going to be higher than the permitted speed. Speed is given the symbol v in physics because it's also associated with velocity, as we'll explain in this video, and its units are meters per second, m/s. Now, we'll calculate speed. We use the distance, which has the symbol s, that comes from the Latin spatium, which means space, travelled per unit time t. And this is the expression. So speed v equals distance divided by time. Now, a useful tool is the formula triangle, where if you cover up any of the unknown terms, you're left with the rearranged equation. For example, if we wanted to know what the distance was, s, we could cover it up, and that would equal v times t, speed times time. Let's look at an example of using this equation. What is the time taken for a racing camel to travel 10 meters at a speed of 5 meters per second? So if now we cover up t in our triangle, or we rearrange the equation, we're given that time equals distance s divided by speed v. So putting in our numbers, we have 10 meters for the distance, and we're going to divide by 5 meters per second for the speed, and 10 divided by 5 gives us 2 seconds. Now, velocity is very similar to speed, but it also specifies a certain direction. If you change direction, then you're changing your velocity. Let's look at an example. In the picture, we see a car A, and let's say it's moving at a speed of 10 meters per second. Now we can see that the cars are on this side are all going in this direction. And it's passing a vehicle on the other side, car B, which is moving in this direction towards us at 15 meters per second. So if we were just to look at their speeds, obviously the difference in speeds is 20 meters per second, subtract 15 meters per second. So the difference in their speeds is just 5 meters per second. However, if we take into account their direction, we can give symbols that show direction. For example, we can say that going away from us in this picture is a positive value. So car A is moving at positive 20 meters per second, whereas car B is coming towards us. So we can give it the opposite sign, and we'll say that's negative 15 meters per second. We've just chosen to give the positive and negative in this way in this example. We could do it the other way around. We'd get the same answer. Now, if we work out the difference in their velocities, so we do the same type of calculation, but we include the signs this time. So positive 20 meters per second, subtract negative 15 meters per second. We would write mathematically like this. Now, if you remember from mathematics, if you subtract a negative, it's like adding the positive number. So now the difference in their velocities is 35 meters per second, which is what you experience if you're on a motorway in a car and you see a car coming the opposite direction. The difference in your velocities seems much greater than the difference in your real speeds. Average speed. Now, when a car is in traffic, its speed will vary. It will speed up, it will slow down, depending on the traffic. Average speed is the total distance divided by the time taken. So let's look at an example. A car travels 2,000 meters in 200 seconds. Its average speed is 200 meters divided by 200 seconds, which equals 10 meters per second. Now, it doesn't mean it's always traveling at 10 meters per second. It could be stuck in traffic at 0 meters per second. It could be going faster than 10 meters per second. All we know is that on average, its speed was 10 meters per second. Let's look at two examples now, and we'll use the equation triangle, the formula triangle that we introduced earlier. The first question is, a train begins a journey from a station and travels 60 kilometers in a time of 20 minutes. What is the average speed of the train? So first of all, let's look at the data we've been given. We've been given 60 kilometers for the distance S, and we've been given 20 minutes. Now, the choices we have, notice that all of the units in the answers are in meters per second. So we can't just say 60 kilometers divided by 20 minutes is 3 kilometers per minute. That would not give us the correct answer. And some candidates might do that and end up with answer A, and they'd be wrong. So what we need to do is convert the data into using units that appear in the answers. So 60 kilometers, hopefully you remember, is 60,000 meters. And we're going to divide that by the time in seconds, and 20 minutes is 20 multiplied by 60 seconds. So if we now put that into our calculator, we will get 50 meters per second. Let's look at the second question. A car travels 100 kilometers. The journey takes 2 hours. The highest speed of the car is 80 kilometers per hour, and the lowest speed is 40 kilometers per hour. What is the average speed of the journey? Now, it would be a mistake to just find the average between those two speeds. So if you did 80 plus 40 kilometers per hour, that's 120 kilometers per hour, divide by 2, and you get 60 kilometers per hour. But that is wrong, because what you haven't done is taken into account that we don't know for how long was it traveling at 80 kilometers an hour, how long was it traveling at 40 kilometers an hour, and all the other speeds in between. So we need to do our physics, and we need to go back to the equation. Okay, so remember, average speed is total distance divided by total time taken. So if we put in those numbers, it was 100 kilometers divided by 2 hours. So obviously we'll be left with now 50 kilometers per hour. Okay, I hope that's given you a good introduction to speed and velocity. There's some optional support here if you want to try to fill in the gaps, or some extension work. Thank you.